record your camera if you're talking, and I do not post the chat. It is recorded, it is sent to my email, and then I delete it. I have no need to post the chat, so feel free to post any questions or whatever you have in the chat to get those answered and whatnot. So we will go ahead and get it started. Oh, look at me, I'm on my very last slide, not the very first slide. Who did that? I did that. But yeah, okay. Welcome, guys, to our virtual meetup. We're so glad to have you here. I hope that it is the 6th, and I didn't. Oh, it is. My computer confirmed I'm right. If you guys want to connect with us at all, feel free to join us on Slack. That link is wrong. I will post a new one. You could follow us on Twitter. We do have an Instagram that I don't post to anymore. Catch our videos on YouTube or follow us on LinkedIn. All of those links are on this slide, and if you want them, I can post them again later. And I will post that Slack link so you can join us on Forge Slack because it's the best Slack in the history of the world. Come on, slides. We do have a job board there. Just because that's not the right, oh, that is the right link. Thanks, Todd. I think that's the right link. We do have a job board there. It's super active. If you're looking for a job or you are hiring, feel free to post on that Slack. That way people who couldn't make it here today can see it then. And then you can DM people and ask them questions about their companies and whatnot. Kind of gives us a little bit of the experience that you would have had in person talking about jobs and stuff. We are looking for speakers for next month and all of the other months. The Women Who Go has a paper call that you can post there. If not, you feel free to DM me and or Clint on Slack about speaking. We're always looking for speakers. First-time speakers are welcome. 12,000th time speakers are also welcome. We just really like local speakers and whatnot. I wanted to say we are having a conference again this year, and by we, I mean me. I am in charge of it, but it is sponsored by Forge as well. The CFP is open. Let your friends know or anybody. We'll be closing that middle of May. And we really like to have it's a regional conference for Utah. Well, the region is kind of like the Rocky Mountain region. So we love having regional speakers kind of to highlight that talent there. And yeah. So today, Carson's talking about Firestore and Go. Funny or not, funny or not. It's kind of funny that he volunteered to do this talk right as I was looking at the Firestore SDK myself. So like I'm super interested because I have some projects that I wanted to use the Firestore with, and since I only program in Go, I need to know about the SDK. So the time is all yours, Carson. And yeah, if you have questions, Carson would love to take them in the chat, or you can just interrupt him or raise your hand. We'll make sure they get answered. But go ahead, it's all you.
Yep, I won't see hand raises, so someone will have to vocalize them to me because I'm gonna. Yeah, well, I can put it over. Yeah, no, I'm gonna have to hide my screen,
we will let you know if hand is raised.
Okay, so 2 things. I'm going to be sharing everything that I'm doing with this super fancy OBS setup that I've got going on here. So if you need to make sure you click the pin to pin me to full screen so that you can see, so I'm not in some little square corner. And then let me know, everybody, if that, hopefully that all works for everybody. But this gives you, I'm a gesticulator, and so having my face, I'm hoping, helps kind of get some ideas along when I gesticulate along with them. Everybody see that? Is that good, Mariah? Maybe?
It seems so, yes.
Okay, perfect. Okay, so thanks for coming. I'm here to talk about Firestore and Go. This is primarily an original production for Utah Gophers. My name is Carson Anderson. I'm a DevEx engineer at Weave. Some background on the DevEx team. We don't build the Weave product directly. Occasionally we do a little bit towards it, but mostly we work on building tooling and other systems for our developers at Weave so that we can enable them to build the product and to maintain and manage the product efficiently. So that's what we do. We do a lot of Go. Weave is primarily a Go shop, and the DevEx team is no exception. We do tons and tons in Go, and all the tools that we make for our developers are written in Go. So I've had a lot of experience with Go and a lot of experience with Firestore. Before I go any further, I want to talk about terms really quick because I'm going to kind of start out. We're going to hype Firestore a lot. I'm going to bring you into it. We're going to dig into a ton of code, and as we go along with the code, I'm going to tear down the things that I think are gotchas or dumb things or whatever. Before we even get in there, though, I want to talk about terms because GCP has a lot of things, but it's not great about naming, and it can get very confusing when you start looking into this. There are three terms that you need to separate in your mind: Firebase versus Firestore versus data store. Firebase is a whole suite of tools. It's this big suite of APIs and data stores and other tools that help you build mobile apps. They're primarily for mobile apps, but as we'll see, Firestore is for everybody, but it lives under that. So Firebase is the suite of APIs. Firestore, which is sometimes called the Firebase real-time database, is a real-time NoSQL database that's under Firebase, right? So Firebase is the top level. Firestore is a piece under Firebase. There is also the legacy data store system, which is the old version of Firestore, not under Firebase, but you can still run it. And we'll talk about the difference between Firestore and the legacy data store. And you'll even see data store come up somewhere towards the end where you still have to use something that's named after data store. So that's a lot of terms, but the talk I'm going to give you is all about Firestore and Go. So that's the whole talk, and everything I show you is specifically Firestore and Go. There is an API and an SDK for the legacy system, but I'm not talking about that. So all that said, what is Firestore, or a Firebase real-time database? It is, on the surface, it is a globally available, infinitely scalable, NoSQL data store, which is awesome. It's completely hosted in GCP. There's no infrastructure to run or maintain. You just start an account and use it. It has a bunch of really great features. It's got all the basic CRUD that you would expect, plus a bunch of fancy ways to do sort of very piecemeal document manipulation. There's live watches of individual documents and collections of documents, and I'll cover what both those are. But live watches is one of my very, very favorite things because it lets me build really reactive things when I'm using Firestore that you don't have to do a lot of polling, that I can give instant feedback to my users. It's got transactions and batch writes, and we'll cover what both of those are and when you use one versus the other. And my second most favorite thing about Firestore is that it's probably free. In fact, this is the main reason I thought it would be a great talk. I don't usually do Go talks that are super heavy in a single product, but if you're just playing around or you're kind of a hobbyist or even at work, there's a good chance that you'll fall under the free tier and not have to pay anything to use Firestore, which is awesome. Of course, it's not free forever, but there's a really, really generous free quota, and I'll cover what that is. So if you aren't hyped enough, I'm going to take 2 seconds and cover how we use Firestore and Go at Weave in order to provide values for our developer. So I'm jumping over here, and at Weave, we've got hundreds and hundreds of microservices, and we need to make it easy for developers to deploy and manage those services. And one of the things you do a lot when you have hundreds of services is build them. We've got a whole CI/CD pipeline set up, but there was really no easy way to get instant feedback about the progress of builds. So you'd push a commit and you'd have to go to another page or load an old API and keep hitting the API over and over again. And so we wanted to kind of move that into something more reactive and better. So if you're a developer at Weave and you've got a service you're working on, we've written a tool for you. And one of the things that tool can do is give you build information. So if I run that tool and I type builds, this doesn't seem like much, but this data comes out of Firestore. And so we were able to put the build metadata out, make it globally available, infinitely scalable for all our developers without having to have them ever.
Carson?
Mm-hmm.
Is that blurry for anyone else? Because my screen is super pixelated. Anybody else? Yeah. So it's super pixelated.
It's because he's not presenting.
Yeah.
So he's got video compression on his console.
Oh, interesting. Well,
yeah, so
hold on.
You're
That's
super
fine.
crisp. I agree. I agree with Todd. And this is a Google Meet thing, Google Meet will take 4K picture and automatically compress it down to 720 or lower based on their throughput rate.
That's fine. Let's do this. I'm going to share just this whole thing, and it's going to be less pretty, but more usable.
Sorry, Carson. Go back.
No, that's great. Thanks for the feedback.
Yeah. It's not your fault. It's Google
No.
Meet's fault. I'm
Perfect.
throwing shade on Google Meet on a recorded Google Meet presentation. But
so,
yeah.
If you look at the sharing one and I go back to that text, is that better for everybody?
I need to unpin you.
Just as bad.
Yes, it's very good.
Okay. Yeah, don't look at my if you're still looking at my screen, if you still see like the weave and the little gopher, that's the wrong thing.
Yeah, unpin
Carson that and look at the.
Yes, that's perfect.
Okay. Perfect. That's great. That's something to know. That sucks because I really like the OBS, but I don't need it. It doesn't. The content is king here. You don't need to see my face. Just imagine me gesticulating wildly. I promise I'm doing it. Okay, so we're all back. Everybody can see it, and it's better. So I just typed Bart builds. Like I said, all that came out of Firestore. And that's just fine. But what we had people doing in the past was, running builds over and over again, and it has to hit and gather all the data. And so we're able to leverage the live watch feature of Firestore so that if I actually go and kick off a build in the background here, and again, I'll show you how we do all of this. I just want to get you hyped for like the end product of what you can build. And it doesn't take a lot of code to build kind of fancier features like this, like live systems. So you see I kicked off the background. Don't worry about the time. Our build servers are out of sync. And it shows up. And as this progresses through, it'll draw a new line each time there's a new event. There's a new build change. So we're able to build a very live and reactive where you want to see the status of your build without leaving your terminal. We got it for you. We also have a secret system that we've built for our developers where if you want to deploy a service into an environment and give it secrets, we do that for you. And one of the things we needed to solve for that was how do we give developers information about the secrets that are available to them, metadata about the secrets. And how do we do that in a way that all the developers everywhere can access it without having to connect to some VPN to get to a certain database? How do we make that globally available, infinitely scalable, all of that? And that was with Firestore. So if I run Bart secret info, you can see that there's some data here. And again, this doesn't seem like much, but this is all instantly available to our devs, and we don't have to maintain any background information. In fact, we can do things like if you put in extra information, we'll run additional queries for you when we fetch this data from Firestore, and I'll show you how to do this, and it will filter things down for you so that you only see specific pieces of data. And we don't have to really write any of this. We just pass it through to Firestore to do all that filtering for us. So hopefully that gets you a little bit hyped to kind of understand some of the final products you can build, and that just barely scratches the surface. We use it for a lot of other things. And again, my favorite part is I don't have to maintain any infrastructure for all of those features. It's all done by Google for me. So if you're going to get started with the Firestore, you have to start by, it's actually really easy. The only thing you have to do is get a Google account. And if you already have one or can create one, that's it. So you get a Google account, you go to consolecloudgoogle.com, and that's it. You can start using Firestore. And just to prove that, I've actually pulled up my own personal account right now. So if I click on here, you'll see this is my own personal email account. There is, I don't even have billing. I'm just going to prove that I don't even have billing set up. So you don't even have to add a credit card in order to start using Firestore, which is great. So you'll log in, you'll come over, you'll find Firestore. And the first thing you have to do for everything in Google, and this is, like I said, a brand new account. I haven't even claimed my free products yet, or my free credits, is create a project. So if I create a project here and I call it Utah Go FS, I'm going to create that real quick, and we'll come back. I'm going to go back to my slides, and we'll come back here in a second. So that's all it takes to start using Firestore. You log in, you go to the console, you create a project, and that's it, right? And I already kind of went through this, except for one thing, and we'll come back to this in a second. This is the first big hiccup I think people need to understand to get past using Firestore because it's scary. It asks you to make some very big decisions up front, and these are permanent project-wide decisions about what mode Firestore is in and where your data lives. And it can kind of make you scared to go forward, and it feels like a wall. So I'm actually going to go to the live page here. So I hit on data, I choose the project that I just made. We're going to get that same screenshot that I just showed you. and give it a second here. I'm going to talk about the decisions you have to make and how they impact what you're going to do. So you get this same screen, and you're like, oh man, this mode you select will be permanent for the project. And it makes you choose these two things. And this is a big decision because it changes the entire API available to you in the project. Native mode is Firestore mode. Again, remember I said their naming isn't great. They're not consistent. This is Firestore, but they call it native mode in this exact page, and I don't know why. Then there's data store mode, or the legacy cloud data store. They both have a different set of features. You can read over this on your own time. The point is that for the entire project, you choose one of the two, and for everything we're doing right now, you have to use native mode. That's where all of the modern features that I'm going to show you live. By the way, if you're scared about this, make a throwaway project, right? If this is a wall and you're like, what if I really needed to use data store mode down the road? That's fine. Projects don't cost you anything in GCP. Make a throwaway, use data store mode, play with it if you think you need one of the features that they're describing in here. But for us, we're going to choose native mode. The next thing you have to choose, and again, permanent for the location. It's very scary. You have to pick a place for your data to live. This is both. It affects both availability and your cost. So you can see you get 5 nines versus 4 nines, and then all these different single regions versus a multi. Short versions of this is I pretty much always use NAM5 because I like the multi-region. I never go enough to make the cost be worth it. But if you're going to use Firestore a lot, it might make a difference to use a single region. And 4 nines is still pretty great for availability in a single region. So we'll click create, and I'll go back to my slides, and we'll come back here again. So don't be afraid of this. If you're really afraid, make a throwaway project. Like I said, these are permanent for the project. You have to choose native mode. Everything that I'm doing, I'm going to show you is native mode. I will point out that not all single regions are cheaper than multi. If you're going to go in like Carolina, it's the same price as multiple regions. So dig into their pricing page if you're really not sure, but you can probably just use NAM5 if you're going to play around, because you're probably never going to get too far past the free for your initial stuff. The next thing I want to talk about, and we'll go back to the other page, is some other key terms. And I know I haven't shown any Go code yet. I promise there's a ton of it coming. I just want to get you a good foundation. Project, of course, is where everything lives in GCP. Everything has to have a root project. So we have a project. Within a project, when we're talking Firestore, there are one or more collections underneath the project, and collections have no actual data associated with them. But inside collections, there are one or more documents, and the documents are where the data actually lives. So let's go back real quick, and I'll show you what this looks like in the console before we get into the code. So once you've made those decisions, you give it a second to create. In this console, you can see that I've got my data, and the first thing I've got here is the ability to create a collection. So if I create a collection, call it customers, you have to give it an ID, and you have to make a document in a collection. You can't actually just create a collection. Even if I try to empty this ID out and just hit save, you'll see it puts a new ID back in. And we'll talk about why this is, but effectively, even though I hit the start collection button, I actually am creating a document inside a collection. But you'll see that I could make another collection here of, we'll just say artists, like they say, and give it another document. Now, each of these documents can have multiple typed fields. So I could call this ID and say it was weave. And you can add a bunch of types, and we'll cover what all these are. The interesting thing about Firestore is that you can have as many collections as you want. Collections have documents, and documents have collections, which have documents.
Carson,
so I could actually
can I make one more request.
Sure.
Can you zoom in just a
Sure.
tiny bit on the browser? There,
like
that's
this?
it. That's
Perfect.
good
Thank you.
enough for me. Thank you, Carson.
Nope, that's what I rely on you for. Thank you. So we've got collections and documents can have collections, and then you can go as deep as you go. You can keep adding and adding and adding. And I'm going to actually kind of describe that a bit more, because it will really help you when we start doing operations to understand those layers and how they interact. So you have to alternate. You have to have inside your project collections that have documents that have collections that have documents. This is the only way that Firestore can store your data. And again, actual bits of data only live in the document portion. The collections only have an ID. They have no extra metadata, which is fine. It's a document store, right? It's not a collection store. But of course, more accurately, like I said, you can have as many collections inside a project as you want. Each collection can have as many documents. Each document can have collections, blah, 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 all the way down as deep as you want to go. And leveraging and understanding the structure is really the key to using Firestore in any language. I know this seems super weird to have this like forced separation, but it's not. It actually is very close to a thing we already do. If you think of like a RESTful API, right? We've got a collection of customers. A customer might be called Weave. Weave has users. The Weave customer has users. Bob would be a document in there. The Bob user in the customer of Weave has emails, which might be, primary or secondary or whatever. So it really, it can work to your advantage, and there's some logic. And the way they've chosen to separate these out, there's it's not completely arbitrary, right? Like it seems forced, but there's a good reason for it. So all of that being said, collections in Firestore don't really exist. This is very much similar to if you use S3 or cloud storage. Collections are just kind of prefixes of names. You can't actually just have a collection exist on its own. And this seems weird, especially because on that UI I just showed you, there's a start collection button. You'd think that the first thing you want to do when you get into Firestore code is create a collection. Well, no. They don't exist. You put a document into Firestore, and if it exists under a collection, that collection exists. And this is actually awesome because it means you don't have to pre-create collections and you don't have to clean them up when you're done with them. You just put documents in the store, and if they need to be inside collections, they are. So don't get tripped up trying to look for a create collection in the API because it won't be there. Like I said, all the data in Firestore is typed. These are loosely the JSON types, but not exactly. And my favorite thing about Firestore and Go is that I don't have to do those conversions myself. I don't have to serialize, do any special additional, like take my struct and put it into JSON before I put it into Firestore. I can just put my struct into Firestore, and we'll talk about that. There are all the JSON types that I already showed you. There's also a few custom types that Firestore supports that are great because they have one-to-one comparisons mostly to Go types. So if you pass a time.time into Firestore, it knows how to deal with that as a time. If you pass a byte slice, it knows how to deal with that. There's also a custom reference type and even a latitude and longitude special geographic point type. I don't use this. I don't know why we wouldn't Go. It's really built for mobile SDKs for like where you draw a box and it finds all the points inside that box. But it is, part of Firestore, so I'm covering it here. Hold on. Yeah. So I already did the UI. We're going to skip that. The one thing I said is you'll probably be able to use this for free, and this is why I love Firestore as an option for hobbyists or even professionally. Per day, you get 50,000 document reads, 20,000 writes, 20,000 deletes, and up to a gig of data. Now, I know a gig of data seems like the small part there, but Firestore is really based around metadata, not storing large files. And so getting to a gig is actually pretty hard. So you could pretty easily fall under this. And I can tell you right now, the first 2 use cases of Firestore at Weave have still not cost us anything. We've since used it for some bigger projects, but both of the build system that I showed you and all of our secret info, so all our builds and all of our secrets for everything in the entire company never cost us anything to this day, because we just didn't go over this per day limit. You can, if you're code wrong, you can hit this, but these are really, really generous. So this is why I think it's a great topic for us to talk about here. So let's get into it. That's enough. You have your feet wet in Firestore. Let's talk about using it in Go. So 2 things you need to do right out the bat if you're going to use it with Go, and that is first go get the package, of course, and then there's an official Google Firestore Go SDK, and the second one is export your application default credentials. I'm going to actually show you what this looks like really quick. So if you come in, you have to get gcloud. And there are ways to do it without this, but if you want to deal with Go, this is going to be your most seamless way and the way I'm going to do everything with the presentation. So gcloud auth application default login. What this does is pulls up a thing where you can choose one of your Google accounts. Yeah, Todd, agreed. You want to do it this way. So you click that, and that's it. That's all it takes. Now I'm authed for my accounts. So once you pull that up, you're done. And what it does is it saves some credentials to a well-known file for the SDK. And it saves them in such a way that when you run your code out in other Google worlds, you won't have to give it credentials explicitly either. So doing this step is critically important, and I'll show you how great it is in the next page here. So if you've done those 2 things, this is all it takes to create a Firestore client, a basic Firestore client. You're going to import the package, get a context, and we're going to call create client with the context and the name of the project we just made. Now, this is a different project that I have in the background, but this would theoretically be that project that I pulled up on this page right here. So this would theoretically be Utah Go FS if I was doing this from scratch. And that's it. And I've created a fully functional client. The credentials that it needs, it will automatically fetch from that exported file that I just made with the login command. If I then take this exact code and I put it on a GCP VM, it's going to get the credentials of that VM. If I put it on a GCP function system, it's going to get the credentials from that system. It uses the default cloud chain of authentication, and I don't need to give it explicit credentials. I'll show you how, but you don't need to. And this is really the cloud way you want to write your auth. Let it get it from the environment. I've got a defer of the client close. This does exist, but I point out because a lot of people think they need it. If you're only going to make one client for the lifetime of the program, you don't need to defer the close. There's nothing that has to clean up on program exit. You only need to close them if you're going to make a client and then delete it and make it again. So we're going to run this real quick just to prove that that's all it takes and I get a functional client. The contents don't matter. I just want to say, like, yeah, that is functional code that I just showed you. Now, I said there are advanced ways and there are ways to supply explicit credentials. One of the easiest ways is to save a GCP creds file to your file system somewhere. Let's say we had it on our home directory under a folder called GCP and a file called creds. And you could, during the creation of Firestore, you can actually supply as many, 0 to as many of you want as you want of these functional options, where you take the option package and there's a lot of these. One of them, I just got some examples here. This is not an exhaustive list. One is to say, hey, add this string to the audit logs. Another one is, hey, I want to create this client with getting credentials not from the default system, but from the full GCP cred path that I'm giving you here. So if for whatever reason you can't rely on exported credentials, there are, this is just one, there are many other ways to get credentials in, but I really encourage you to use this simplest format that I'm showing you here. So there we go. We've got a client. Let's start doing stuff. Here's an example, and I wanted to talk about how I don't have to do a serialization in Go and Firestore. I can just put structs into Firestore, and we'll show you what that looks like. But I want to show you that Firestore is pretty robust. You can deal with complex structs just out of the box. So here's a customer that I've got. It's got an ID and a name, which is basic strings. I've got nicknames, which is a slice of string. I'll come back to these in a second. I've got features, which is a map. I've got a slice of another struct. I've got a pointer to another customer. I've got an anonymous child struct, or even this special lat long, which is the upstream type that Google has that will convert natively over to that special latitude longitude type. Just to show you that these really complex things, these all work when I put them in Firestore without any special consideration. There are two exceptions to this. One is that unlike JSON, when you put this into Firestore, it's not going to lowercase your public methods, right? So if I were to put this document in Firestore, I'm going to get a capital I, capital D field, and I'm going to capital N name field. JSON lower cases and YAML lower cases or Pascal cases by default. Firestore just keeps them as is, unless you use the struct tags. So Firestore supports the exact set of struct tags that you could use with the JSON library. So if you're used to using struct tags for JSON saying, hey, I want you to don't rename it, but omit it if it's empty, or I do want you to, instead of using features, call it feats, or skip a field entirely. This is all possible, and those tags worked for Firestore just like they would with JSON, but you don't have to supply them. So this whole struct would work as is. So that gives you an idea of like how you can customize without having to really write any functions the way that your documents are stored and handled in Firestore. So let's make something. If I'm going to make a document in Firestore using Go, I'm going to get my client like I showed you. And the first thing that I need to do almost every time I'm going to do anything with the document or collection in Firestore is get a reference to that document or collection. And the way that we do that is by taking our client and calling .collection and giving it a collection name. That gives us a collection ref. Most of the time, the thing we do on that is call .doc and give it a name or an ID, and it's going to give us a reference to the Weave document inside the customer's collection. Now, there's a reason I'm calling this a reference and not a document. Document refs, the thing returned by that function I just showed you, are handles to documents. And there's two things about them. They never contain actual data. Document refs are purely references. And just because you can create a reference to a document does not mean it exists. Even if an API call or a function returns a reference, that doesn't mean the reference exists. It's purely speculative. So you'll notice there's no error here because there's no network call happening. This is purely a speculative reference to a document. But it's the first thing you're going to get, and I'm going to show you a lot of them. So we go ahead and we create our client like before. Here's that document ref I just showed you, and I'm going to run this code, and we're going to print the path from this document ref. There is one other hiccup that will bite you if you're not aware of it, and I'll show you that in a second. But there are also more complex ways. So you can, in a document ref, you can actually put slashes yourself, and rather than do the .customers.weave, you can actually just put a slash there. You can do the same thing with a collection. You can create a collection without going through the intermediary .document.collection calls. You can, and this is the most common one, get a document ref, add a path, right? So I'm saying I want the document under the customers collection, under the weave document, under the users collection, under the Bob document. These 4 references are 100% valid way to get references, and you'll get a usable value back. I tell everybody, use this top method. Don't put slashes in your IDs ever if you can avoid it, unless you really, really need to, because if you don't follow the rules, remember you have to go collection document, collection document. If you don't follow those rules, you will get nils back from these function calls. So these bottom 3 are invalid. This one's invalid because I'm missing a component. This one is invalid because I want to get a document at a collection document collection, right? So you can't get a document if it's the third thing, if it's an odd number of components. And I can't get a collection if I'm getting a collection and then a document. And I know I'm saying these words a lot, but the important part is it can be very hard to track unless you use Firestore a lot, unless you call these alternating methods. So this is the way I tell you to do it all the time. And I'm going to run this to show that these top 4, they gave me a valid path. They give me a valid object back that I could call .path on, and the bottom ones returned nil. And so if you try to call .path on them, you're going to get nil panics at some point. There are several of the Firestore SDK functions in Go that will handle nil references and not complain at you, but they might print a warning. So really, takeaway, use this alternating system to get a reference. So let's create something. For crying out loud, that's enough. Let's start doing the cool features. Let's create things. I'm going to get a document ref using the way that I say you should. And in order to create a document, all it takes is take your reference and call .create. So you're saying, at the place that you're referencing here, I want you to create a document, and here's the struct, and that's it. Remember, any weird nuanced stuff about how I want to exclude fields or rename fields or deal with serialization in Firestore, that's all defined in the struct. So I can just create the struct directly. I'm going to get a result back from the create operation and an error, and we'll handle that, and I'm going to print the result in a couple different ways to show you what happens when I call create. So that worked. I created my document. What I get back in the result is just a time. And I've printed the verbose form of this struct for you here to show that, yeah, if you dig in, there's only a time that's returned. So if we go further in to the SDK, you'll see that when we call create, it returns a write result and an error. And the write result is actually returned by lots and lots of methods, and it is just the update time. This means that most of the time, the write result isn't useful to you. So 99% of the time, I just do this because I don't need that. I don't care what the update time of the document was. There is exactly 1 or 2 use cases where this is valuable, and I'll show you how to do that. But most time, you can just safely ignore it. So that's the first thing. When you do a create, unlike some other SDKs, you don't get your document back. You just get the metadata about the operation. So let's get our document back explicitly. So if we take our reference, and I'm going to kind of just show you the pertinent parts as we go. So we still had to create this doc ref like before. And instead of calling .create, I'm going to say .get. Get me the document under this reference. And it's going to return a document snapshot. Now, right here is where the network call happens. Once you've done this, all of your data, the network has been hit, and you'll never hit the network again below that if you want to get data out. The data is inside of document snapshot, but it's not immediately obvious that it's there unless you've used the SDK a lot. So if I print out, and I'm just going to dump everything in there, you'll see that in that snapshot, we've got the reference where the snapshot came from. We've got some metadata, and it doesn't look like our data is there. If you kind of do public methods on this, you won't see it. But I promise you the data is stored inside this object in memory at this point. What you have to do is a few different things to get data out. So there's actually several options of fetching data out of a snapshot, and you'll actually get snapshots from the Firestore SDK and a couple other places other than just the get. But if we do our get here, remember this is where the network call happens. Now I can use the snapshot as much as I want and I never hit the network again. The first and primary way we do that is we create a customer and a pointer to a customer struct, and we say take that snapshot and put all the data in the snapshot into the cust. So this is very sort of JSON YAML, standard serialization method where you say, hey, whatever you've got, stick it in here. And this is the way we do it most of the time. Now, if you don't have a struct or don't want to define a struct for maybe it's some document someone else is putting in Firestore, there are more arbitrary ways to get data. You can say, take that snapshot, and instead of putting in a struct, just get me the piece of data under the name key. Now, remember, this is capital N because Firestore doesn't Pascal case our methods or our documents when we put them inside Firestore. You can also get all the data out of the snapshot in this sort of very, very arbitrary map string to empty interface system, which can be handy. And I'll show you how getting the data out in this format, you can actually do a little bit of manipulation with it without having to have a struct. But I really recommend, if you've got structs, use this top method. But let's just do it real quick and show you what you get out. So here's that customer I put in the previous page. Here's me extracting it into a struct. Here's where I get just the ID, or sorry, just the name field. And then here's that map of string to empty interface. So if I didn't have a struct, I could use this map system. So there's a couple ways that once you've got your snapshot, there's all the ways that you get your data out. Let's talk about manipulating. So we've done a create. Let's talk about changing the data in a document. So one of the ways that you can do this, and the easiest way, depending on the kind of data you have, is just to do a set. A set is sort of an all or nothing upsert of your entire document. So we're going to say, hey, take our reference. Again, everything happens on docrefs. And we're going to call it .set. We'll give it the context, and just like with create, we give it a struct. Now, what set does is takes everything in the data you're giving it and completely overwrites whatever is there if there's something there. So if it doesn't exist, it'll set it and upsert it. If it does exist, it will overwrite it. So remember, right now, customer has the weave customer, this same docref we've been setting this whole time, actually has 3 fields set. But the struct I'm putting in here only has 1. So if we call that, and in the background, I'm printing it out. You can't see that code, but I'm just printing it out again. Now I've completely overwritten whatever was at the weave document ref, and I've lost these 2 fields. Now, most of the time, set is really useful if you've already got a struct and you just want to change one thing and you want to put that whole struct in there, but it's, you can actually wipe your data if you're not careful. You can get fancier with your set if you want to use it, but do partial manipulations. One way to do this is called .set just like before. In this case, I'm only going to give it an ID field, but what I'm going to do is use a functional option on the set function to say, hey, do a merge. I know that I've given you a struct with a lot of fields, but I only want you to merge in the data from the ID field and leave everything else alone. And you can do that. And you'll see that even though I only had the ID, it left the name from the document from the past page. There are better ways if you want to do piecemeal manipulations, but I want you to know that this merging option exists. And even further, there's a merge all option. If you're saying, well, I don't want to iterate and list all the fields in my struct, one way is with the merge all. Now, the catch with merge all is that it only works on arbitrary map to string empty interface. You can't actually give it a struct, and it'll have a compile time error if you try to give it a struct. But you can call merge all. And what that says is, say, here's a map of arbitrary data. I want you to put it into this document, but only merge in the fields that are set in the map. If I didn't set it, don't set it in the document. So if I run that, you'll see that, hey, even though this only had the location data, it didn't overwrite the other 2 because it knows how to automatically merge just what I put into the map. These can be useful in certain situations. Merge all is specifically useful if you don't have a struct for a document. You can do a document get, convert it to that arbitrary data struct, do some sort of piecemeal manipulation, and then set it with a smart merge. If you want to do just patches of individual fields, I actually recommend not messing with merge, and instead you use the update call. So if you're saying, hey, I don't care what's in there, I want to set 1 field in a document. And most of what I do in Firestore is either a set where I completely stomp with no merge options, or updates. Those are my 2 main calls that I personally use in Firestore all the time. Updates are easy. Updates, you build a slice of Firestore update structs. Those have a path, meaning the field in the document that you want to manipulate, and a value, meaning what you're going to set. So you build that update list, you take your docref, again, everything's on docref, and you call .update and give it that list. And it's going to do, it doesn't matter what's in the document at that point in time. It's going to say, hey, this is a series of manipulations I want you to run against that document. And you can see that even though I didn't define almost anything here, it just tweaked that one piece of the document in Firestore for me. You can get fancier with this, by the way. Their update is really, really flexible. So here's the basic one I showed you. I could also add fields that aren't in the document, so you're not limited to just changing fields that exist. I can even add nested fields into my document. So here I am saying under hiring, make a new URL, make a new hiring group, and then a URL field inside that. Same thing with referred by. I could even have keys in Firestore that support really weird special characters. Now, in Go, I would really discourage the use of this, but it's technically possible in the SDK. We're going to call .update and then get the data back and print it out to show you what it looks like. Now, importantly, I'm not putting it into a struct because my struct isn't defining all of these things right now. If your struct did, that'd be fine. So here's just an example of how update is actually really flexible, and you can put nested data in your document and create data, even special fancy key data if you need to, without having to worry about building a struct for it. You can also do conditions on updates. This is the one time that I said, remember I said we would talk about when you might use the snapshot information, or where you might use the update time returned by a .get. And that is for doing sort of race condition detection. So we're going to pretend I have two servers that are running the code on this page. Server number one is going to get a document snapshot at a point in time. In the meantime, after server one gets the document snapshot, server two is going to do an update on my document. And then server one has since tried to schedule a document ref update for that document that it got. Said, hey, I want you to change the name of this document and only apply these changes if the document you're changing has the update time of the one that I last got, right? So you can kind of sort of do detection, say, only make this change if the document I'm working on hasn't changed since I looked at it. And if we do this and run the sample code, you'll see that, yeah, we get this failed precondition. And Firestore detected for me that, hey, the document you're updating is not the one that you originally saw, so I'm going to cancel this operation. It lets you do sort of race detection if you need it. Again, this is completely optional. Most of the time I don't use this, but if you really, really need race detection, you've got it. Deletes are super basic. I have almost nothing to say about them. You take your reference and call delete. It deletes your object. So if I show you that, we're going to see that, okay, yep, it deleted that document for us. So that was super basic CRUD. And kind of hopefully I gave you an idea of everything that's available to you. Again, there are very specific pieces of that I use most of the time. Most of the time I just do creates. Most of the time I just do sets with the whole document or piecemeal patches. But all those options are available to you. Let's talk about getting multiple documents out of Firestore, right? Like it's great to be able to manipulate one document at a time, but what I really want is do a lot of documents at once. So one way that you can get multiple documents out of Firestore is actually getting all of them based on a query. So we, as an example here, I'm saying, okay, take the client, get the collection of customers, and I want to run a query against that. And I want to find all the customers where the name is one of these two names, and I want you to limit by 2. I can then take my query, get the documents iterator on it, and then call get all, and it will get all of the documents that match that query and store them inside this list of snapshots. I'm going to then print out how long it is and iterate through them and dump the data in each snapshot. So in one call, I'm going to fetch all of the documents that match my query. In this case, it's just 2. You also, by the way, you do not have to you can actually do a .all straight on the collection. So if you don't want to do a query, you have a couple options. You can actually just take your client, get your collection, and call the documents iterator straight on it. You don't need the query in the middle, and it will get, if you don't add a new line, it will get all the documents that match. I only have 2, so even without the query, I only got 2. But this is how you get multiple documents. It's just as easy as that. And notice that if I'm picking a specific collection, by default, I will only get documents in that collection. And this is one of the things I really want to drive home. You want to understand the collection document system of Firestore, because you oftentimes don't even need queries if you properly structure your data to be nested the way you want it. Queries have, if you do want to use queries, they actually have a whole bunch of SQL type things in them. They have wheres that I showed you. You have sorting, limiting, you start and end, paging. You have a lot of very SQL style things that you can put on top of a Firestore query. But be super careful about using queries to an extreme degree, because they can bite you really hard. And I want to show you on the next page what I mean. Here are 3 different Firestore queries that are all invalid. All of these are invalid, and they seem very, very reasonable if you're coming from a SQL world. So the first one gets all the customers where expire date's greater than a certain date and onboarding date is less than a different date. The third one, or the second one here, gets all the customers where expire date is greater than a certain date and orders, which seems reasonable. The last one gets all the customers where expire date is equal to a certain date and orders by a different date, right? So these are 2 different filters. These seem very, very reasonable. These top 2 are completely impossible in Firestore, and the bottom one is possible if you do some extra work. And I'm going to actually print and show you that these errors are there and kind of show you what I mean. So here's those errors. They'll give you the detailed reasons why. I'm not going to go into it because that's too far in the weeds even for me in this talk. But the takeaway is that be very, very careful about queries. Test your queries early in the development process to make sure that all the ways you plan on getting your data out of Firestore, that you can actually run those queries. I've got a link here in my presentation, and I'll have a link to the whole talk where you can get this document. And that goes over exactly what queries are valid or invalid. The TLDR on it is equalities are fine. If you're doing a lot of equalities and maybe a single sorting or ordering by, you're probably okay. It's when you start doing not equalities or multiple orders that things get weird in Firestore. Really what you want to do as much as you can in Firestore is try to group your documents into collections that are logical so that you don't need to, for example, rather than try to get all of the customers that have a certain name and then order them by a different date, you would put all those documents in a dedicated collection and then just filter by that collection. That's how we solved a lot of our problems, is by making more sophisticated, dedicated collections and then not needing to query. So queries are there. You can use them. They're really great if you're doing a lot of equalities, but be careful and test them early. So that's kind of the very, very basic operations. Let's talk about my favorite features. The first one is watching. It is possible in Firestore to do a live watch on either a single document or a collection of documents or a query of a collection of documents and get those updates the moment they happen. And this is where really I think Firestore, besides the fact that I don't have to run any infrastructure, this is one of my favorite things. As a note, when you do a query or watch, every time you get a document in that stream, that counts as a read for your quota. Remember, we have 50,000 of those for free per day. But if you do a lot of watches and you read all, if you have 10,000 documents and you want to watch that whole collection, you could use it up pretty quick. So again, lots of smaller collections is your friend, especially when it comes to doing these watches. But if I wanted to do a watch, it's actually really, really simple. I create a doc ref just like I would before, and I'm going to take that ref and call .snapshots on it, and that returns an iterator. And the iterator has 2 methods, a .next and a .stop. Now, here's what I'm going to do in the background of the next slide, so you kind of queue up for what you're going to see me run. But this isn't the watch. This is what I want to do in the background before we do our watch. I'm going to schedule a doc create. I'm going to schedule an update, and then a different update, and then a delete. And then we'll just stop the iterator. So remember, in the back of your head, for the next page, we're doing a create, update, update, delete. Now, this is what actually consuming that iterator looks like. You take an infinite for loop, and this is very similar if you've done any sort of read line parsing in Go. It's a very, very common pattern. We call iterator.next. It gives us a snapshot. Remember, I said we get snapshots from multiple places in the SDK. When you do a .get, you get a snapshot, and in iterators, you get a snapshot. And then we get an error. We check for a special error case to see if that iterator was gracefully canceled. Otherwise, we worry about the error. And the first thing you need to know is that when you're doing document watches, sorry, right, the R is for, I think it's just the other part of create, CR, create, update, delete.
Oh, that was for anybody. Thanks, Carson.
Sorry, I'm just
Yeah,
shouldn't even look at
I
that.
was like totally thinking. I had no clue. Okay, go ahead.
Yep. When you're iterating through and you're doing this infinite loop, just because you've got a snapshot and there wasn't an error does not mean that the snapshot that is given to you exists. It is incredibly critical that you check the exists function and don't try to use the snapshot if exists returns false. So that's what this check is. It's an early check to say, hey, I got a snapshot, but it doesn't exist. And we'll cover when that happens. But once I've gotten past this check, I can, just like before I've got my snapshot, I can use any of the data methods I want. Data to, get all the data, get data at a specific point. I'm just going to get that data into a struct and then dump it. So let's run. And remember, in the background, when I click run, we're going to do a create, update, delete on the document that I'm watching. So if I start the run, the very first thing that happens is I get an event instantly that says the document does not exist, right? So I got a snapshot the moment I ran that watch before the document was even created, but that snapshot was for a document that doesn't exist. This is just the way it behaves if you try to start a watch on a document that's not there. I then get my create, my update, and my delete. And so there's a few takeaways that I want you to get from what we just saw. So we got a snapshot that didn't exist, and we got our 3 events and another snapshot that didn't exist. Before I go further, I'm giving you so many caveats and I don't want you to get bit, but this is awesome. This is almost no code to have a live watch on a document in a data store I don't have to maintain, that's globally available, that has free auth. Like, that's awesome that this is all it takes to say, hey, I want to keep an eye on a document and tell me the moment that this changes out of the data store. Like, imagine the infrastructure you have to run if you want to even try to do this. And you can't do this with SQL. You can't do this with, maybe not with Mongo or some of these other NoSQL stores. Like, this is no code, right? Like 100 lines of code, and that's a lot of that is empty space to get docs. And yes, you can watch many docs. I'll show you that in a second. So I'm starting out with one, and then we'll talk about watching lots of documents. But before I get into the caveats, like, that's not much code for a really cool feature. So because I talked and interrupted it, let's do the demo one more time. We get an event, we get create, update, delete from that document watch. The things I want you to take away: it was basically impossible to tell the difference between an add and an update, right? They looked the same. We just got a document in our code. You could try to track internal state and see if you've seen the document before, but really, these are very hard to tell the difference between an add and an update when you're watching, and you shouldn't try. Deletes, if I hadn't been running my watch when the delete happened, I would have missed it. It's also very, very hard to tell the difference between a delete or the document not existing at all. So I would say, don't rely on catching events and don't rely on event types and watches, right? Use the document itself to track its state. So if you want to, say, clean up something when a document is deleted, put a field in the document to describe whether or not it's had its cleanup done, and then use the content of the document to decide what you should do. This is how Kubernetes does deletion of resources. It doesn't actually delete things. It sets a timestamp and then has a list of operations that should happen before the document actually goes away. And if you want to do that same kind of thing, I encourage you to do it. Always, last piece, always use .exists before trying to use a reference, because it might not actually exist if it's been deleted or doesn't exist yet. So, like you just asked, David, we've got watches of queries or entire collections of documents. So if you say, well, it's not just, no, it doesn't actually. So it is possible. Hold on. So sorry, he just asked, is it when you delete a document, does it cascade to all of these sub documents and sub collections? Actually, yes, it does. If you call delete on a document, everything inside of it is deleted. But it is still possible to have what they call orphan documents. So you can actually create a document that's multiple layers of documents and collections deep without pre-creating the intermediary documents. So it does do auto cleanup, but it is possible to have sort of phantom documents that exist. To kind of answer 2 questions that one of them you didn't even ask. So let's talk about whole collection watches. If you go look at the docs for Firestore and Go, they have a little section that says like coming soon, and they say that, but it's absolutely in there. I don't know why they don't just describe how to do this, because it is absolutely possible to do collection watches with Firestore in Go. They have sample code for every other language, but they just have like a not yet implemented in the Go box, and I don't know why. So I'm going to show you how to do it because they won't. We create our client. we'd get a collection, a document ref. It doesn't have to be a deeper. Any collection can have a query off of it. So we'd take this query, and on the query, and even if I don't, notice I'm not putting any constraints here. So this is effectively a query for all the documents in this collection. You could do .wheres and all those other things, but if you don't, it's the whole collection by default. We call .snapshots. And what we get on that query .snapshots call is an iterator, and that works just like our iterator for documents with a small exception. So again, I'm going to prime you for what I'm going to do in the background before I show you how to use the iterator. So in the background of the next slide, I'm going to be doing this. I'm going to 5 times sleep for a second, create a user, and then update that user document inside the collection that I'm going to be watching, right? Because I want to see this, I want you to see this happen live. So just know that in the background, I'm doing some creates and updates. In order to actually use the collection iterator that I just showed you how to get, it's just like with documents. We do an infinite for loop, we call .next, we check for the special error exit, and then do something with our snapshot. If we go further in, I'm going to show you what is inside that snapshot. So remember the .iter next returns this snapshot. And then on the next page, because we're watching a collection, we're not going to get just one document snapshot. We're getting a snapshot which contains a series of document changes, sometimes for the same document. So we're going to iterate over the slice of changes. We can check the kind. Now, don't trust this. I'm going to show you why you don't want to trust this, but theoretically, in this list, there is a kind that tells you whether the change was an add, modify, or remove. So what I'm going to do is loop over each set of changes, check the type, and then print a special message and dump the document for all types. This can lead you astray when you see this kind switch and make you think that you can trust it, and you kind of can't, which is it's fine. It's the way that the nature of the beast. So in the background, I'm creating every second a new user, right? So we saw them drip in. I added and then modified the users with that background process I showed you earlier. And all 5 of those happened. Now, this seems pretty reasonable, right? You look at this and go, hey, I can look at when the user is added and do something different than when a user is modified. Well, yes, but no. If I run this same code again with those 5 users already created in Firestore, instantly, they didn't drip feed in. They all instantly showed up, and they all showed up as added. And not only did they all show up as added, I'm not getting the changes. Because remember, the background code is doing an add, update, with a second rest between each set of operations. Added, when it comes to Firestore collection watches, really means added to your watch session, right? It doesn't mean actually the document is added for the first time. And so you really, just sort of like with document watches, even though you got this kind, don't trust telling the difference between an add and a modify. If you need to do some sort of document initialization, put the status of that process in your document and just seek state all the time. Don't trust these events. I almost always fall through between the two. Yeah, so be very, very careful about these. I usually just have a fall through in here and then do the same thing for adds and modifies. And again, I don't trust deletes to even do state changes. And then I just missed another question there. Is this more of a webhook watching the document? No, this is, I think it's a long HTTP call. I'm not sure the exact background technology that they're doing in order to do this watch. But you know, there's no incoming message to you. This is 100% the client going out, so you don't have to have anything listening. So I will just prove that if I hit a remove and I clean up those 5 documents, I will get those events again, right? Because the create, update, like those do come through, but again, don't really trust these. Oh, and the other thing I wanted to mention, because it's on the next page as well, if I do this watch again when the documents exist, my modifies don't come through. I only see those initial adds for the 5 documents that exist. I don't see modifies, and we'll talk about that. So caveats to watches. Add events happen for all existing docs in a collection or query on the start. Updates don't get sent if there was no actual document change. So even though I had a background process calling .update, since the document didn't change, I did not get an update event. So be careful that if you want to watch updates, you're actually making a change or you won't even get the event. You could just set a timestamp or something if you want, but you have to do some kind of change to your document. Every single time you get one of those, it counts as a read for your billing. And then don't trust catching events. These systems just aren't built for that. Put state in for doing processing of state change. Don't try to do much with those event kinds. it's a bad practice in my opinion. So that's watches. And again, so many caveats. I don't want you to get bitten. I want you to understand upfront limitations, but this is not much code, again, to watch all the documents in an infrastructure I don't have to maintain. And I could have hundreds of different separate instances putting documents or manipulating documents, and I can just set up one watch really easily and not have to maintain network connections or background infrastructure. Like, I'm giving you a lot of the caveats and dirt on this, but it's really cool at its core. There's a reason I use this for a lot of things, because this can give me, this is how we did our watches of our builds earlier, right? Like, I just have a watch on the builds collection, and then I tell you when a new build comes in. So there's a lot of cool stuff in here. Another really cool thing about Firestore is transactions. So beyond just basic CRUD, Firestore has transactions that you can do, and it can go up to 500 docs per transaction. They're really built around doing gets along with updates. We'll talk about what that really means. All transactions are 100%. You do the transaction completely or none of it happens. And transactions in the SDK have automatic retries. So it'll try the transaction multiple times if there's a problem doing an update. So what does that look like? There's a lot of code here. I'm going to just talk to it one line at a time. First thing I'm doing is saying, take my client, get a collection of customers and the Utah Gophers customer. Then off of that customer ref, notice I don't have to always call from client. If I've got an existing reference, I can actually just iterate and build a collection or a document off that reference. So you don't always have to start from scratch. You can actually build references from any sort of reference that you're given. So I'm going to say, off of this customer, create the users collection, or go into the users collection and get the Carson doc reference. So I'm going to, before I even start my transaction, I'm going to create the customer. And then this is all it takes to run a transaction in Firestore. You call client.runTransaction, you give it a context and a callback function. Now, critically, one of the things that you receive in this function is the Firestore transaction pointer. You have to use this for your .gets, your updates, your deletes, whatever, in order to actually have them be part of the transaction. Even though you think, you inside here you do client.get or client.create, that's just going to happen outside the transaction. You have to use this T object.
Hey, Carson, we got a question on your snapshot stuff.
Sure. I see you looping through the snapshot changes. Does it batch updates? Yeah. So if we go back to, I don't think it batches updates. It does it very, very quickly. So it doesn't like sit there and hold. Like, you will, if you're doing a watch and someone adds a document, you'll get that really quickly. I'm sure it batches it, but by default, it's a very, very fast batch. So most of the time you're going to get one or maybe two, unless you have tens of thousands of users putting documents in Firestore at once. Most of the time these snapshot batches are actually very, very small. So it does do batching, which is why we get a whole series of changes, but the size of those batches is usually very small. So thank you. And there are, I'm sorry. Yeah, we're going to get about batch writing here in a second. So transactions are one thing. I will talk about batch writes in a different, on the next slide. So transactions are really when you want to deal with getting data and creating and manipulating documents as it relates to the content of other documents. So going back to my code, get a customer ref, get a user ref, creating the customer. I'm going to run the transaction, and here's my callback function, and I'm going to be sure to use the T for all my operations in the transaction function. So first thing I'm going to do is do a t.get, and I'm going to say, get me the snapshot for the customer at this customer ref. Now, when I do this, during the course of the transaction, I now have a lock on this document. Nobody else can update or change this document during the rest of this transaction. So this is the main feature of transactions versus batch writes, and I will show you batch writes, is that you can get and lock documents for the course of a transaction. So I've got a snapshot. I'm going to then extract the name field from that snapshot. I'm going to use it to create a user where I'm building that user's name based on the customer name that I just got and locked the document source. And then if for whatever reason either this get or the create field fails, say the get doesn't exist as a main use case, like this customer doesn't exist, I would fail out early and it would never even fall down to the create. Or if the create fails, then my gets happened, but if I had done other updates, they would all be rolled back, right? So if I wanted to get a customer, and put 10 users in there, if the 10th user fails, none of the user creates would have happened. They'll all get rolled back automatically. So I'm going to show you just doing a simple transaction. This probably isn't useful, but again, I can make sure that the customer exists when I do the create and for the duration of my create. So that's really nice to do these transactions. Inside a transaction, like I said, you've got get, you've got delete, set, and update, all the main things that you would expect from Firestore. All the same CRUD we already talked about. There's also a get all, which is a really poorly named function because it doesn't get all your documents. It gets a list of, it's really like a fancy for loop around get for you. But that's transactions. Getting locks, pessimistic locks on documents for the course of a transaction is what transactions are really built for. In fact, they're built so much for it that you can actually call them in a special mode where you say, I'm not even going to read data during this transaction. I'm going to actually skip that. So we're going to say, hey, I have a transaction. I only want to do these locks. So I can, in my transaction, as a functional option at the end, I can say, hey, run this in read-only mode, where I'm not even going to do updates. And I want you to just get customer, then get user, lock both of these two so no one can change them while I potentially do something. In this case, I'm just printing out their data, and then unlock them when I return. So if you have a lot, again, you can see how so much of this is built for mobile, where you just have tens of thousands of users potentially manipulating the same documents. There's a lot of really good things in here to help you not do concurrent ops. I almost never use this, but this is all available in transactions. The simpler thing, and the thing we were kind of just talking about, and what you really want to do most of the time, is probably batch writes. Transactions are great if you need to get documents and lock them, but if you want to just do big bulk operations for Firestore, it's batch writes that you want. These are all about doing just changes. So just like the transactions are 500 per batch, and they work a little differently. So in order to do a batch operation, I take my client and I call .batch, and now I get a new batch. Now I'm going to iterate 5 times and create a user ID, then create a docref for that user, and then queue up a create. Now there's no network call happening on this create. It doesn't even return anything, you'll see. It just says, hey, queue up a create of this user in my batch. It's when I call commit that it sends all of the queued up operations to be done, again, just like with transactions, all or nothing. So if I make the first 4 users and it works, and then something goes wrong for whatever reason in Firestore on the back end, and the 10th one can't be made, it will not have made all the rest of them. So you don't have to worry about partial changes. It will handle that for you as part of the commit. The one thing batches don't do is auto retries. So if you want auto retrying in a batch, you do it yourself. But I think this is the most common use case where I want to say, I'm going to do big bulk operations. I'm going to use batches instead of transactions. Batches have almost everything a transaction has except get, right? So it's called batch writing, but you can also do, updates and deletes and the sets and all the things that I showed you in basic CRUD. So the last page on that is the difference between these, and I've kind of covered this. Batches are pretty much always faster, and they don't worry about concurrency. Batches are they're both atomic, which is really the main takeaway I want you to have. And I'm not going to read this verbatim, but you can see that I've kind of covered all of these. Most of the time I do batches. I haven't really had almost any need for a transaction. Most of the time a batch write is really what I needed. So take from that what you will. There's a couple more things I want to cover before we're done here. The first is, how do we lock down Firestore? And one big caveat with Firestore is the way it works with Go isn't great for policy. So you remember that I created some credentials with gcloud. Those credentials are tied to my GCP user, and I can give my user or any other GCP user roles in my project. The 2 roles that are associated to Firestore are roles data store user and roles data store viewer. And this is where I said some of these names leak from the old system. And yes, Matthew asks, can batch writes take place all over the place and not within a single collection? Absolutely. Yep, you can do batch writes across as many collections and documents, and I'm keeping it simple, but there's no restriction about which collections documents live in. So batches, they're just big bulk operations. Moving on to security. So if you go to add these policies and you look for Firestore in the roles, you're not going to find it. You have to look for data store user and data store viewer. And these are the read write and read only equivalent roles. Now I will say, when you give a user one of these two policies in a project, they have access to all collections and all documents in the entire project. That's the only way that Firestore works with Go, is it's all or nothing. Whatever level you get across the entire data set for the document or for the project. Of course, the advantage is that there's no extra cost for using these roles, right? You can use the GCP standard IAM stuff and these policies for free. Don't get caught up, by the way. I really am driving home that those are the only way you can do it, because if you start Googling Firestore additional security rules like I did, there is such a thing as Firestore security rules. But in the fine print, they only apply to the mobile and web SDKs, not Go. Go does what they call server-side authentication, and it doesn't have, so you can define these rules to your heart content. You can learn everything about Firestore security rules, and they'll never work with your Go code because that's not how Go authenticates. So that's something to be aware of. Don't get sidetracked. I don't even explain it here because, frankly, I've never been able to use it. My advice with Firestore security is, because access is project-wide and because projects are free in Google, there's no cost to have a lot of projects, I always recommend make more projects to make more granularity. And hopefully that's enough for you, where you can say, hey, this collection's sensitive. I'll put it in a dedicated project and just give 1 or 2 users access to that project. And then, yes, it's project-wide, but that project only has 1 collection, so it doesn't matter. If you can't do that and you need really nuanced, complex access policy, you might not want to use Firestore. And that's just the truth about how it works with Go. It's not built for complex access policy that's server-side. So don't, and I say this as somebody who wasted probably a whole day or half a day on my own trying to like make these rules work. And I was setting up the rules and they all validated, and the UI has a nice, pretty UI for these rules, and they never worked. And then it's, oh yeah, they don't work for Go. There's also other restrictions. So now that I've shown you all the cool things you get you get watches and batch writes and all these transactions and all this cool stuff in Firestore probably for free. Like every cloud system, there are limits. Each individual document in Firestore has to be less than a megabyte in size. So their max size is a megabyte per document, which doesn't seem like much, but that's a lot of metadata. Most of the time, if I have to have a ton of data, what I'll do is I'll put the metadata in Firestore and then have a reference to like a cloud storage URL or cloud storage location where the actual big bulk data lives. So keep Firestore really limited to just metadata. Collection and doc IDs have like character limits, and almost every single field, like there's a limit on how big any individual string field can be. And there's tons more of these. I've got a link here to the Firestore quota page. Again, this is sort of like with the querying, like these caveats come with check your edges early, check your queries early, check your maximums, document sizes, and like field sizes early to make sure that you're not going to hit a wall with some sort of, and this isn't just Firestore, this is every single cloud service. They all have limits. One really great thing about Firestore, and the last thing I want to talk about, is that it has an emulator. The emulator is written in Java, which we won't talk about that, but that's just what it is. But it's got a full-featured emulator that supports 99% of what Firestore itself can do, and it's great for running integration tests. So the way you use the emulator is you install it. You go to this page and you install it. In a terminal, you start, and I always say start just the Firestore part of this emulator. Remember, there's a whole Firebase suite of tools. I'm just talking about Firestore. So if you run this, you've got a background emulator running. And the only thing you have to do to change it, to use it, is before you run your code, export an environment variable that says, hey, the emulator lives here. And then that's it. You don't have to change your code at all to tell it to use the emulator. It will just detect this variable and use it. In fact, it works so well, everything I've been showing you in this presentation, except for one page, is running off the emulator. So all of this, I haven't had to actually use any of my quota or even be connected to the network theoretically in order to do this whole presentation, because I'm using the emulator. And this works perfect because every time you start the emulator and shut it down, it starts with empty data sets. So it's great for integration tests or unit tests, depending on how you want to describe your terms. By the way, the only thing that didn't work in this was the bad queries. It just panics. It doesn't give me detailed error messages when you run really bad queries. So that was the only thing I could find that didn't work with the emulator. Literally, watches, updates, transactions, all of that is just fine in the emulator. So before I go into my credits, we're hiring. So if any of this seems really cool to you, Weave as a whole is hiring, and we have 2 job postings for the DevEx team. So if you want to work in a lot of Go and you want to work in Firestore and other Google products and build new reactive tools for developers, come work at Weave or the DevEx team, and make sure you reference me. So that's it. That is a lot of talking. Hopefully that is a good balance between the realistic things of using Firestore and the hype. And so I tried to go back and forth of hype machine, what it's really like, hype machine. All my code, all my sample code, and this whole presentation, you can pull it down and do a Go present to run it yourself. And that's on this. I don't think I made it public yet, but I'll make it public at the end of this once I'm done here. And you can go find what I'm doing. So thank you.
Do we do silent, like, yay claps for Carson? That was awesome. I learned so much.
Yeah, so hopefully that gets you started, Mariah. I know you.
Yeah. Well, I already have, like, the Firestore tools. I just need to upload my information. I'm super excited. Super duper excited.
Awesome.
Cool. Do we have any additional questions for Carson?
I do have a question. So you mentioned using the snapshot timestamp to kind of do, it has built-in detection of the dirty write style conflict mitigation.
Correct.
How often do you use that versus the transactions? Because transactions, I think, do have a bit more of a performance impact, like slow it down a bit. Can you often get away with just detecting the dirty write instead?
Yeah, I mean, most of the time I do dirty write detection, or I just do the group updates, right? Like almost so much of my operation is literally I just want to change like 2 fields. And so I find the update really to be what I use more than anything. So
nice.
I think I've used transactions once and I've used it update probably like 50 times.
Nice. Cool. That's awesome.
And we use batch writes a lot, but that's just because we needed to do a bunch of mass inserts of data into Firestore. But it's cool. I mean, theoretically, I don't know if I'd ever want to do this, but if you have that kind of dirty write detection, you could do even leader election with Firestore, right? Like you've written it with etcd and Kubernetes, because if you can tell that somebody else tried to grab a thing at the same time you tried to grab it, like you could theoretically write a whole leader detection mechanism that had Firestore as that. So, which would be actually, now I really want to write a Vitesse topology server that uses Firestore.
That's absolutely disgusting. Just stop.
Well, I already wrote the Vitesse one that uses etcd and Kubernetes, and so we could just say, hey, use Firestore as your topology. And I think they're getting rid of it, but if they weren't, man, that would be cool, because it's got watches, it's got transactions, it's got leader detection, it's got everything that we need out of any modern key value store that would let us write anyway.
I don't think they have any sort of like heartbeat though. Like there's no SLA on those lock style things. You would have to implement your own heartbeat style read or something, right? Like,
well, the way it works with any of the other data stores for leader detection is you just try to, or like if you use Kubernetes for leader detection, you just try to get the lease object, and if 2 of them try to get the lease at the same time, then it detects that you're conflicting, and then you have a lease for a certain amount of time, and if you don't renew it, somebody else takes over. So you don't have to actually do heartbeats. You're just kind of using the document to. It's not instant leader detection in Kubernetes, but it's fast enough depending on how you configure it. But you're right, there is no heartbeat or anything.
Okay, I'm getting beeps that somebody keeps raising their hand.
That's our Google Meet applause while muted.
Oh, nice.
Oh, God. Like it beeps in my headphones. Gosh.
That's great.
Oh, my.
So yeah, we use it a lot. It's been completely free, our main use, and I loved it. Like it was months, and we're still not we haven't paid anything for all of our secret metadata to be stored in Firestore. So how do you beat that?
I've got one question. So I'm not really from Utah at all. Can you explain what Weave actually is?
Sure. Do we have Mariah also works there. I don't know if we have like the
Ooh, I want to take a shot. I want to do it.
Todd doesn't work there, but I want to hear his description.
Okay, Todd, what is Weave?
Okay, Weave is a provider of integration software for primarily dental clients, but anybody with like an office and a schedule of appointments and things to automate making those appointments, calling out reminders of those appointments using VoIP and stuff, and managing the interactions with like your CRM and your dental software and stuff to coordinate who's coming in, who are they, what's their file, etc.
Yep.
That's probably one of the better ones I've heard.
It's sort of like if you've ever called a dentist, a doctor's office, a veterinarian, optometrist, and they knew who you were without even asking, and they were able to like schedule appointments through text or immediately say like, oh yeah, so and so, I see you've got an appointment coming up on Tuesday. Like that experience is something Weave facilitates.
Okay, yeah, I think I've had that, like when I called the company to get information and they're like, "Hello, your name," and it's like, that's creepy, but but it's funny.
But it's super nice. Like it is a little creepy. Like, where did you get that?
Yeah,
But
yeah.
the truth is they've always had that data. We're just making it easy to use and get value from it.
Cool, thanks.
Yep. And I don't push Weave at all. I'm like, I work for them, and I other than pushing that we're hiring and stuff, this was purely my passion for the code. So, any other questions? Firestore stuff. Hopefully that I got you excited to go use it and know where you'll get bit and not get hung up in all the places I got hung up when I first got started. So, again, you can go use it today. It's free.
It is.
I take it all the normal JSON caveats apply, like with nulls and stuff.
Yeah. I mean, it deals very much like. Well, sorry. Explain your caveats specifically.
Well, I mean, I am not as well versed as Zach, my friend. But we had issues with like parsing JSON that had null fields, and it would just be like not null, like you would expect. It was like an empty string or something instead.
Oh,
yes.
okay, for Go, yeah.
All the exact same Go serialization things apply. So omit empty, for example, that's how zero values work in Go, right? So
yep.
Yes. If you say you have a document defined and you've got a string in there, or it's not even a string. Can I go back to I want to talk about this because I like this. I always harp on this stuff. And this is how Kubernetes and everything that does serialization in Go works. So can everybody see? Can you see my thing? Am I still sharing it?
Yeah.
Yep.
Oh, you're omit empty.
So this, if you put a nil in here and then you put it into Firestore, the sibling key won't even exist because nil is the zero value for a pointer to customer. And so if I put omit empty in here, it would say, okay, you've told me to omit empty. Pretend this struct tag is down here. And nil is the zero value for this. And so I won't even put the sibling key in your document. If this wasn't a pointer to customer and was instead a full customer, and you just put an empty customer struct where you didn't set any values, it would put an empty map here because you can't do zero detection of structs. And that's how JSON and Firestore and YAML all work is omit empty can only compare against the zero value of things.
That's also why some of the other methods use the map explicitly instead of taking a struct. Is in the map you can control that better too.
Exactly. Yep. And so the hardest part I find with that is when when the zero value overlaps with a logical value. So one example of this is like Kubernetes has a replicas field right in the deployment, and it has to be a pointer in the struct inside the Kubernetes Go code. It has to be a pointer to an int because otherwise, if you serialize, you had omit empty and you serialized an int of zero, it's going to say, well, zero is the default value for int. And so I'm not going to send this to the API, and then it made it impossible to actually send an explicit zero. So sometimes you'll see pointers in weird places, and you have to use pointers in weird places because you want to explicitly tell the difference between empty string or not providing that string at all. And if you don't have a pointer, you can't distinguish those two situations. So yeah, and this is not Firestore. If you use any of this, you end up making sometimes pointers to things that don't need to be pointers, just so you can, again, tell the difference between I didn't set this versus I explicitly set it to this empty attribute. So yeah, you're right. All that still applies. But I love the fact that I don't have to do the Firestore SDK does all that marshalling and marshalling for me, right? I don't have to get another JSON or YAML or any of that involved. I can just put structs into Firestore and take structs out. So I didn't show it here, but this UI is not great for creating documents, but it is always setting up live watches for you, which is kind of cool. So if I'm in here and someone were out of band to add a user into this collection, it would just pop up. Or if they were to in code change an attribute about the user that I was looking at, like change this ID, it would live in the UI show these changes as they happen. So it's a terrible way to make and manipulate these documents, but it's really good for having this visual. And of course, all the stuff I've been doing isn't in here because I did it in the emulator, but it's great to have this way to visually explore your data that you've created in code. So even though I don't encourage the use of it for, other than like really break glass data manipulations, it's nice to have this UI. And I didn't go into some of the other, non-GUI things. Like I said, this security rules page, don't even believe it because it doesn't apply to anything but mobile and web. So it makes you think you can do really cool things that we can't in Go. It does have usage, so you can track where you are in your quotas for the day and where you've been over time. So like, there's a lot of cool stuff in this UI. I really leaned heavy in the Go code, but there's more here that you could explore.
Cool. Well, if that's all we've got for the moment, I'll stop the recording. Thank you again.
Mm-hmm.
Recording. Stop.